Hello, friends. Today we will be talking about some properties of real numbers which we use blatantly in our real life. And we will now enumerate these properties and how they are helpful to us. So, what is it and why we need it? These are the two answers that I'm going to give you for each of the properties. The first property that we will be talking about is commutativity. Now, what do you mean by commutativity in real numbers? So, in real numbers, commutativity is a property that will be satisfied with two operations: one, addition, and second, multiplication. So, when you add two numbers, real numbers, say A is one real number and B is another real number, whether you add A plus B or you take B plus A, it should not make any difference. Ordering does not make any difference when you add two real numbers or when you multiply two real numbers A and B. So whether you multiply A multiplied by B or B multiplied by A, it's going to be the same thing. So 2 multiplied by 3 is 6 and 3 multiplied by 2 is also 6. Similarly, A plus B, if you take 2 and 3 again, so 2 plus 3 and 3 plus 2, both will give you 5. So it will not make any difference. This is very easy to actually see. And why do we need it? We need it because, so what happens is that to simplify your additions, to simplify the operations, it's important that we know this property. For example, suppose you have to add 7 plus 25 plus 3. 7 plus 25 plus 3. Parenthesis is here, 25 plus 3. Suppose this is how you have it. Then I know by the property of commutativity that I can write it down 25 plus 3. I can write it down as 3 plus 25. So I made these brackets only for you to use commutativity here. Now, why have I done that? I've done this for a simple reason that I'm going to add 7 and 3 first. And the moment I do that, I'll get 10, which is a very easy number to deal with because now I know that I have 10 plus 25, which clearly is 35. So it just simplified my calculations. So commutativity is a property which is helping you to calculate things in an easier manner. Okay. So much easier. It makes your life much easier. Now, when we talk about A multiplied by B or B multiplied by A, it's the same thing. Ordering, again, does not make any difference. So ordering doesn't make any difference. And that's why if, let me just take an example for this one. Let me just take an example for this guy here. So if you have to multiply 4 by 28 and 5. So if I want to know the product of 4 multiplied by 28 multiplied by 5, and I know that commutativity works. So what I can do is I can use commutativity here and I can write this as 4 multiplied by 5 into 28. And now I can first multiply 4 and 5 and I'm going to get 20 here, which again is a very simple number to multiply this expression with. So simply, I can just now, multiply 20 and 28, and I'm going to get 560, and that's going to be your answer. So again, what have we done? We have simplified using the property of commutativity. Something that we have used here, inbuilt used here, is called the property of associativity. So if you understand the property of commutativity, it's easy to understand the property of associativity. Now, associative, real numbers are associative. Associative means, in terms of addition, that if you multiply A plus B plus C, if you add, A plus B plus C, it is equal to A plus B plus C. So where you put your brackets will not make any difference. The parenthesis will not make any difference. Okay. For example, so if we take an example, minus 5 plus 6 plus 4. Now, to simplify the process, what I'm going to do is I'm going to write minus 5 plus, I'm going to put the brackets out here. And I'm doing so because I know that 6 plus 4 is 10 and it'll be easy. It's generally easier to work with the multiples of, 10, 5. It's easy to do that, right? So 6 plus 4 gives me 10 and I know minus 5 plus 10 will give me 5. So just making things easy or simpler for us, nothing else. Now, what is important for us to understand in here? We deal with variables as well. So can I use this with variables? Absolutely, yes. Let's take an example with variables. Let me take an example with variable y. So I have an expression with me where I'm adding y plus 2. I'm adding y plus 2 to 5. So it's y plus 2 plus 5. But if you understand, y and 2 are not alike. Y is a variable. I can't really add it to 2, right? So what instead I can do is I can use associativity and I can say that its expression is absolutely same as y plus 7. So again, it's simplifying the situation for you. And this is what these rules mean. They are here to simplify. They are generalizations. When we say properties of real numbers, that means it will be satisfied by all real numbers. So if y is a real number, but we don't have a value for it, that is why it's a variable, I can use associativity to, simplify an expression like this. Similarly, let's take the case of multiplication. So as far as operation multiplication is concerned, yes, the real numbers are associative in nature. So which basically means that if I first multiply A and B and then multiply it by C, it's going to be the same as multiplying A to B, C. It's going to be the same. So what is happening here is that you can rearrange factors. You can rearrange factors here, just like you were doing in commutativity also. You can rearrange factors here. And similarly, what we have done here, we have rearranged groupings. We can group in different way and our answer will be the same. We can rearrange groupings and here we can rearrange factors. Rearrange factors. Example. Let's take an example of this also. So suppose you have minus 4 multiplied by 2 multiplied by 5. Now what I'm going to do here is I'm going to keep minus 4 out here and going to shift the parentheses here and 2 multiplied by 5. So which is going to give me minus 4 multiplied by 10, and that's absolutely simple. I know my answer is minus 40, right? Now please keep in your mind that these two properties, commutativity and associativity, do not hold for subtraction and division. I'm sure if you give yourself examples, you can get the counters. Next property, which will definitely hold for all real numbers, is identity. So you have, in real numbers, you do have an additive identity and a multiplicative identity. So what is an additive identity? An additive identity would be A plus 0 0 is such a real number that if you add it to any number, you will get that number itself. So 0 plus a would also be equal to a itself. And this is also an important property of real numbers. And why is it important? We generally use it without naming it. We use, while solving equation, we use it a lot. So an example I'm going to give you in terms of equations. Say you have y minus 2 equals to 8. You have to solve for y. Now, if I add 2 on both the sides, then what am I going to get? Minus 2 and plus 2 will give me 0. So I'm going to get y plus 0 is equal to 10. And I'm sure you know that by now, y plus 0 is nothing but y. So I have the value of y. So what have we done here is that by adding plus 2, I got the expression y plus 0 equals to 10. So that means I have identity out here. 0 is the identity element out here. And this simply means that y is equal to 10 because what I would be getting is y plus 0 equals to y itself by the additive identity property. So that's what is additive identity. Now, identity doesn't just stop here. We have multiplicative identity as well. And multiplicative identity is basically a number which you multiply by a, you will just get a. So 1 is that real number. If I multiply a number a by 1 or 1 by a, I'm going to get just a. So that's your multiplicative identity. Now, multiplicative identity, how do we use it? I'm going to give you an example in terms of fractions. So we blatantly use it in fractions. How? Let me just make you realize what we actually do. So suppose you have 7 upon 2 plus 2 upon 3. Suppose you have 7 upon 2 plus 2 upon 3. Now, clearly, the least common divisor, LCD, is equal to 6 here, right? It is 6. Now, let's try to make both the denominators of 7 by 2 and 2 by 3 6. And how can I do that? Now, if I multiply each of the fractions by 1, the fractions are not changing. So I will try to multiply the two fractions by 1 in such a manner that denominator for both is 6. So what do I have to do to make the denominator of 7 by 2, 6? I should be multiplying by 3. So I'm going to multiply this by 3 upon 3. 3 upon 3 is 1. Plus 2 by 3. So what should I multiply 3 with so that I get 6? 2. So 2 by 2. So which gives me that I have the expressions, 7 into 3 upon 6 plus 2 into 2 upon 6, or in other words, I have the expression 21 plus 4. Since the denominator is the same, I can take it common and it's 6. So, or in other words, it is 25 upon 6. 25 upon 6 is what you get here. And what have we done? We have actually, in some way or the other, used the property of multiplicative identity. Let's work on the next property, inverse. So real numbers have this property that for multiplication operation and for addition, you have additive inverse and multiplicative inverse. Now, what do you mean by inverse here? So when it comes to addition, inverse essentially means that there must be another real number. In case you add that another real number to the real number A, what you get is the identity element 0. 0 is the additive identity. You get 0. So there has to be a number which you add, you will get 0. So minus A plus A must give you 0. Now, how is this important? Remember, in the previous case, in the previous property, we took an equation y minus 2 equals to 8, and we added 2. We added 2 on both the sides, and that gave me y plus 0 equals to 10. And that was happening because minus 2 plus 2 gives you 0. And since there is additive, 0 is the additive identity, I know that this means that y is equal to 10. Now here we are also able to actually get something apart from identity, which is inverse. The concept of inverse also comes out of here. So what you essentially got from here is that minus 2 is the real number that you started off with. If you add the number 2 to it, you will get the identity element 0. So that's what is an inverse. Inverse in case of multiplication. So if your operation is multiplication, what is inverse all about? So the concept of inverse all about is when you multiply a by, so you multiply a number with a, and what happens is that you get the multiplicative identity 1. So that number is 1 upon a, which is essentially there's another name to it, reciprocal. So the reciprocal of a number, of a real number, is essentially the multiplicative inverse. So a multiplied by 1 upon a gives you 1, or 1 upon a multiplied by a gives you 1. So that is what is the reciprocal or multiplicative inverse. That is what is the multiplicative inverse. Now the question, why we need inverse relation or inverse property? Why is it there? So suppose I'm going to take a, with variables, I'm going to take an example with variables here. So suppose you have 6 upon 7 times x is equal to 1 by 3. Now my attempt will be to get the value of x. Now how would you get it? So what we can do, we can multiply. If you multiply this number, by its inverse, that is the reciprocal. So which is, since this number is 6 by 7, so reciprocal would be 7 upon 6 multiplied by 6 upon 7 times x. Now I'm multiplying on one side by 7 by 6. That means I will have to multiply on the other side also by 7 by 6, so that the equality doesn't change. Now what's going to happen here is 7 cancels out with this 7, 6 cancels out with this 6, and what I am left with is 1 multiplied by x is equal to 7 upon 18. And what is 1 multiplied by x? 1 is the multiplicative inverse. So this is nothing but x is equal to 7 by 18. So that's what is the property of inverse in terms of multiplication. Next comes a very important property, distributive property. Now, distributive property would relate to both addition as well as multiplication together. And it's very crucial for us when we are working with variables and all equations. So suppose you have a multiplied by b plus c. So a times b plus c should be same as a times b plus a times c. It should not be different. Similarly, if you have b plus c multiplied by a, even that should be equal to b times a plus c times a. So this should happen with all the numbers, which is easy to see. When you just have numbers, it's very easy to see. So if I have 2 multiplied by 3 plus 5, that means it's 2 multiplied by 8 That means it is 16. If I may break it, I should be able to break it. And if I break it, I will get 6 plus 10. That is also 16. It's going to happen. Definitely, it's going to happen. Why we need it? Why is this important for us at this junction to know about it and to mention it? Is because suppose you have variables in picture. Suppose you have a statement with variables. So suppose you have 4 times x minus 2. Now, x and 2 are not really like each other. They're not alike. So I cannot really subtract 2 from something called x, which is not a number as of now. I don't know what number it is, right? It can take different values. That's why it's a variable. But all I know is that this is going to be same as 4x minus 8. So 4 times x minus 8. Going to be same as 4 multiplied by 4 times x minus 2. And this is pretty important for us when we work with variables. For example, suppose you have 4 x squared plus 2x. Now, what I can actually do here is that I see that both these expressions, 4x squared and 2x, are multiplied by x. So what I can do is I can actually take x common. I can say that this is equal to x times 4x plus 2. 4x plus 2. And suppose the question is that, solve for x when 4x squared plus 2x is equal to 0. Then what is beneficial for me? Instead of keeping the expression like this, more beneficial would be to make it into product of two factors like this. What are we doing here? We are using the distributive property equals to 0. We are using the distributive property here, right? Why it would be more important for us? Because, or more helpful to us, because I know that the product of two numbers will be 0 only when at least one of them is 0. So I can easily solve using product of factors here by taking x common. And this brings me to another property, the zero property. The zero property. Now, what is the zero property? The zero property essentially is that if you multiply any real number by the number 0, you will get 0. And that's what we use there. So what we had, x times 4x minus 2, right? This is what we got. We had 4 times plus 2, sorry. Yeah. So this is equal to 0. Now, this is only possible when either of them is 0. Either it is 0 into a equals to 0, or it is a into 0 equals to 0. So that means either x will have to be 0 or 4x plus 2 will be equal to 0, which means x will be equal to minus 2 upon 4, that is minus half. That's all I wanted to discuss in this video.